Hello and welcome to today's lesson. Okay, last lesson in Logic and Reasoning 1. And our goal for today is to look for and identify other patterns. We looked at addition patterns, we looked at multiplication patterns, but this is one pattern. So all we're looking at here is a specific type of pattern that happens very often in a number of basic phenomenon, and it's what we call the handshake formula. Okay, so it seems like a handshake is just one single thing, but when we look at how the handshake pattern or handshake formula works, this applies in a number of scenarios. Okay, so if we look at this situation, what we're trying to do is we're trying to follow the pattern just like we always have in other situations. So we know if there's one person at the party, no handshakes can happen. Okay, so that's our 0 value. If there's 2 people, we can have 1 handshake. 3 people, we can have 3 handshakes. 4 people, we've got 1, 2, 3, 4, 5, and 6 handshakes. Okay, so what we're doing is we're trying to build out this pattern. So for 3 people, we have 3 handshakes. 4 people, we have 6 handshakes. Okay, when we look at 5 people, we'll have 10 handshakes. 1, 2, 3, 4, 5, 6, 7, 8, 9, and here is 10. Okay, so we have, I don't know why I wrote a 7 there for the 10, but let's get that right. And then if we had 6 people, the number of handshakes would be 15. Okay, so now we look at this pattern. We always want to start thinking addition, start thinking subtraction. Okay, we're looking at the difference between the two. So here we've got a +1, +2, +3, +4, +5. Okay, so now the hard part is it is a continually increasing situation, so we can't build a traditional function out of it. So when we think about our scenario, normally we would go multiplier times n plus or minus our starting value of b. Well, the hard part here is what would I use for a multiplier? I can't use 2, I can't use 3, I can't use 4. This function, what we call a linear pattern, only works when that addition or subtraction is the same. So when we're looking at the handshake rule, it's not a very noticeable function, but it's a function that we just want to get used to and, basically come up with and use whenever we see the pattern. And the formula for the handshake rule, function of n, or function of x, but let's use n for our number of individuals, equals n times n minus 1 over 2. Now, let's test this a couple times. Okay, let's look at 3. Let's do the function of 3 and see if this works. 3 times 2 is 6. 6 divided by 2 is 3, so it works. Let's try it with 6. Okay, plugging in 6 into the handshake function. 6 times 6 minus 1, which is 5, is 30. 30 divided by 2 is 15. Okay, so that is the handshake rule, number of people in a scenario, but it's not limited to just handshakes. Okay, so we already kind of went through this piece, okay, but let's look at this situation. Okay, you have a fantasy football team. Okay, it is in a league with 10 other teams. Okay, so we have you and 10 others. Okay, so there are 11 teams overall. How many games will there be in a season? Okay, a game is just like a handshake between 2 teams. So this is a handshake rule situation. So what we would have to have is the handshake rule function based on 11 teams. we would have 11 times 11 minus 1, which is 10, divided by 2, okay, and there would be 55 games that would happen. Okay, we have 11 times 10 divided by 2. I made life a little easier by dividing by 2 with the 10 to get 5. 5 times 11 gives us 55 total games played in that scenario. Okay, so now looking at some other situations that follow this pattern. Okay, lines passing through the same point are concurrent. Okay, we want to know how many regions do we divide the plane into in this situation. So one line divides into 2 regions. Okay, 2 lines divide into 4 regions. 3 lines divide into 6 regions. Okay, so we're looking at the pattern, following the pattern. So we've got 2, 4, 6. 4 lines are dividing into 1, 2, 3, 4, 5, 6, 7, 8 patterns. So this is basically your pizza cutting scenario here. You know, if you make that cut through a plane, how many pieces do you create? So we've got 2, 4, 6, 8, 10. So now what we want to notice here is, what do we have happening? Okay, we've got a constant situation here. Okay, every value is going up by 2. So this would not be a handshake situation. Okay, this would be a linear process problem. Okay, linear process can always be done 2 ways for your function of n. Okay, you can do 2n plus b, pick a point, plug it in, and make sure you solve for b to get the value you're looking for. 2 times 2 is 4. 4 plus b equals 4. Okay, so in this scenario, our b value is 0. Okay, best case scenario we can have. So for any given situation, it's just 2 times n. Okay, and you might have noticed that pattern right off the bat. You know, I'm going math teacher on it. Okay, I didn't look for the pattern. I was following the mathematical process. Okay, now looking at another situation. We just got a couple situations here to finish up. How many diagonals can I draw from only one vertex? Okay, so it is a 4-sided shape. I can only draw one diagonal. Okay, this one, okay, those are consecutive vertices. Those aren't really diagonals. Okay, so a 4-sided shape, I can get one diagonal. Okay, a 5-sided shape, I can get 2 diagonals. Okay, so we're always just trying to build our table. Sides of the shape, number of diagonals. Okay, so a 5-sided shape has 2 diagonals. A 6-sided shape, picking a vertice, seeing how many you can draw, okay, would have 3 diagonals. Okay, so we're always looking for our pattern and following through. Okay, once again, if we finish up with our 7-sided shape, we've got 1, 2, 3, 4 diagonals that can be drawn from that one point. So what we need to do now is we need to understand, you know, what's happening in this scenario. How can we build the equation to model this for any situation? Okay, we notice we've got a +1 scenario. Okay, so we have +1 times n for our function of n, and then we have to figure out what our plus b is. What's the adjustment that has to be made to make the pattern work? And we can always find that value by plugging in. We know that the function of 5 is 1 times 5 plus b, but it also has to equal 2. Okay, so how can I do 5 plus something to equal 2? In this case, b would have to be a minus 3. Okay, so now we have our regular function, and we always want to test it with another value. Make sure that your function works for a 6. So if I'm going to plug 6 into this new function, 1 times 6 minus 3, does that equal 3? Okay, that's always our question mark. And if it does, we know that our function is working correctly. Okay, and we're always just trying to identify what the b value is, and our equation would just be 1n plus, or 1n in this case, minus 3. Okay, so the handshake rule is one property, but we want to remember that sometimes we just have a straight multiplier situation like we did here. Okay, here we have a multiplier situation where we had to make the adjustment on the equation to make it work. Okay, last scenario we'll look at here. Okay, once again, four-sided shape, but we're always trying to do total diagonals here. So in this case, total diagonals are 2. In this case, I've got 1, 2, 3, 4. Okay, and we can't go here to here, but we can go here to here. Okay, so a 5-sided shape has 5 total diagonals. Okay, when we're connecting all of the different vertices that we can. 6-sided shape, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and you want to make sure you're just going through and saying, okay, I already have this diagonal. How many do I need to finish? And then when we look at our 7-sided shape, okay, for 7, okay, always pick one to start with. 1, 2, 3, 4. Then go to the next one. 1, 5, 6, 7, 8. We go to the next one. I can't go here, but I can go 9, 10, 11. Here, you're trying to see which ones can't you do. Okay, 11, 12, 13. Can't go here. And then finally from here, I've got 14 to finish. Okay, so we're looking at, is there a pattern in this situation? And here we've got a plus 3, plus 4, plus 7. God, what am I doing? I can't add today. I apologize. How about a 5? Let's make that work right. Okay, so we've got a 3, 4, 5 situation. Okay, so we have to see what we can do in this scenario. Doesn't fit a linear pattern because all the values are different. Doesn't fit a multiplier pattern. Okay, so we have that issue. So what we always want to do is test and see, does it fit the handshake pattern of 4 times 3 divided by 2? Okay, and in this case, okay, if we're working with the handshake pattern, that one doesn't work. So sometimes we have some situations that don't fit into a good natural rule for us, okay, and we just have to know and be careful. We could follow the pattern on if we wanted, and in this scenario, we could try to see what we could do. We know that, this is always based on our number of sides minus 1. Okay, is the increase that we're getting. Okay, so we have the number of sides minus 1. And then what is the ultimate adjustment that we're making to that, okay, to get what we're looking for. So we're always looking for a scenario, seeing if it works, Okay, it's not always going to work overall, because what I'm looking for here is, how can I take this n minus 1, plug in my sides and get 2 for an answer. So we're always looking for what can we multiply by, how can we work through that to solve. We can try some n minus 1 times n. So now we've got 4 times 3 is 12, but we have to get it down to a 10. So we have to subtract 10 to get it to a 2. Okay, we can see if that would work with the 5. So 5 times 4 is 20. 20 minus 10, okay, doesn't quite work there. So we could try to find the situation to make this work. Okay, finding that formula. Okay, sometimes the formula doesn't work in a nice, clean pattern to solve. We can see what's happening. We can follow it out with a plus 6, a plus 7. But to get to something that can build an equation for us is something that is a little more difficult. Okay, I'm going to dive in on this a little bit more, okay, and I'll add in a video when I've got